Hello, I'm Mr. Brewer at Seven Lakes High School. Today in my academic physics class, I gave my students a problem. They had to determine the horsepower of a car. This car. Okay? They were given a car like this, a little toy car, little string attached. They had paper clips and a meter stick. And they had to determine, work together, and figure out what they needed to do to determine the horsepower of this car. They were provided this additional information as well. They were shown a picture, and the problem, of course, is to determine the horsepower of a toy car. They gave them the wattage, or watts per horsepower, and the equation. Some background information, and to make sure they get this as well, is they had to determine what symbols were opposed to the units. Sometimes with work and power, they get the symbols and units turned around, so we got to be careful there. So for work, the symbol for work is, of course, is W, which is found in the equation. The unit found with a number in front of it, of course, is joules for work. Same thing as for energy. For power, the symbol for power is P, but the unit for power is watts. So they had to determine this. So once given this information, they had to get together and determine the power of the car with the use of paper clips and this and the meter stick, and determine the power it generated in watts, and then convert to horsepower. So they did a video. The first video was like this. They had to run the car. So they pulled the car back and let it go. And when that happened, it pulled up some paper clips. And they had to determine the time it took to pull the paper clips up, as well as the distance. So I pulled up the paper clips, how far it pulled up. Okay. So once they determined that, then they went to the equation. Okay. Had the certain given here. They had the mass of 8 paper clips. They had 8 paper clips, which is about 1 gram each, comes to about 8.0 times 10 to the negative 3 kilograms. Force of gravity is G, and the height was 0.3 meters, centimeters, 30 centimeters. And the time was about 2.5 seconds, approximately. Okay, but they followed the equation. So what they did was they asked the question, what they need to know, how they're going to solve it. Then they had to run their experiment to find out if they solved the problem or not. And again, they had to determine the power. So by looking at the equation, the diagrams, and working together, they determined the mass, the G, or they had the G and the distance and so forth. So then they just plugged and chugged the numbers here. They found the kilograms, which is your mass. Then they have, of course, acceleration of gravity, and of course the distance which it traveled, and the time it took, which of course comes at the power. The unit, of course, is in watts. So they determined by mathematical equation there, and they were able to determine the watts. From the watts, the next step is they say, well, what's the conversion to horsepowers? Now, horsepower is not deal with a lot of times in physics, and maybe we should, because in the real world you talk about horsepower of an engine, car engine, lawnmower engine. They hear horsepower a lot, so why not do a quick conversion so they have an idea between the two? And that's what we did. So I determined the horsepower here. So success was found by when they determined that the horsepower of the little car here by using a number of paper clips. One of the problems ran into, of course, the number of paper clips. Too many, it wouldn't lift. Not enough, it flew off the table. So they had to find the right number that took the paper clips to a certain point in a certain amount of time. They had to make sure they maxed out the power of the car and convert it to watts. Other than that, they did a great job, worked together. They followed the scientific process, but they had to solve the problem together. Ask the question, what do I need to know? What do I need to find out? Did I find out? How do I design an experiment to find out? Then the very end, does it make sense? That's power. And of course, there's 7 lakes. There is no retreat. There is no surrender. That is Spartan law. Have a happy physics.